Hey everyone, welcome back to my channel. This is Introduction to Trigonometry Part 4. Now if you're new to this channel, I highly recommend you to please pause the video and go check out Part 1, 2 and 3 first before you continue with this video further. I am using NCERT CBSE Grade 10th Math textbook to make these videos on trigonometry. I will leave the link of the textbook in the description box below. Please feel free to check it out. The book is available online and it's free and it goes by chapters. So right now I'm doing chapter 8, which is the trigonometry introduction chapter. Okay, so let's continue with example number 3. So example number 3 in the textbook says there is a right angle triangle ACB, and in that you have AB, which is given as 29, and BC is 21. And the acute angle is angle B, which is I have named here as angle theta. And they are asking you to find cos square theta plus sine square theta, and they're asking you to find cos square theta minus sine square theta. How can we solve this problem? So we need to find cos and sine theta first, right, in order to solve this equation. Now, I don't know if you remember the mnemonic from last time. In order to find cos and sine theta, we are using this mnemonic called so, ka, cho. So basically, S for sine, theta is equal to O is opposite and H is hypotenuse. Same thing, C for cos, theta is equal to A is adjacent and H is hypotenuse. And then T is 10, O is again opposite and adjacent. But in this problem, we just need to find the values of cos and sine. Now, what is opposite, what is adjacent, what is hypotenuse in this triangle ACB? Now, the side that is opposite to the right angle triangle, which is angle C in this triangle, is called hypotenuse. It's also known as the longest side in the triangle, right? And then whichever angle we are taking in our example, for this one, it's angle B, which is angle theta. The side opposite to it is called opposite, and the side closer to it, it's called adjacent. So we have these two values, 29 and 21. We need to find this one in order to find the values of sine theta and cos theta, and then we can solve these equations. So let's find the values of AC. Now how can we do that? I'm just going to erase this real quick so we can use the room here. Okay, so in order to find AC, we are going to use Pythagoras Theorem, right? So Pythagoras Theorem says the longer side, the hypotenuse square, is equal to the square of the other two sides, which is the AC square and the BC square. So now we are trying to find AC square, so I'm just going to rewrite this equation. So AC square is equal to AB square, and then I'm setting BC on the other side. So here it's positive, so it becomes minus, so minus BC square. Okay, now we know the value of AB, which is 29 square, and BC is 21 square. So that's 841. 29 square is 841 and 21 square is 441, which is equal to 400. So AC square is equal to 400. Therefore AC is equal to 20, right? If we take the square root of 400, it gives you 20. So this side AC is 20. Now we know all three sides, right? We know side AB, which is 29, side BC, which is 21, and side AC is 20. Now we can find the values of sine theta and cos theta. So what is sine theta? Sine theta is opposite, which is okay, let's erase some of this here. Okay, so sine theta is opposite over hypotenuse, so sine theta is 20 over 29, and cos theta is adjacent over hypotenuse, so it's 21 over 29. I hope you are with me so far. This is just basically, we just use the mnemonic and the Pythagoras theorem to calculate what are the values of sine theta and cos theta. Now we just have to plug those values in these two equations to find the values of these two equations. So let's do that. So what is cos square theta? So cos theta is 21 over 29, and square plus sine square theta is 20 over 29 square, right? So what is this? This is 441. 21 square is 441, and 29 square is 841, plus 20 square is 400, and 29 is again 841, which is equal to, because the denominator is same, we can rewrite the equation as 441 plus 400 over 841, which is equal to, okay, let's erase some of these formulas here so we can use some room. Which is equal to, equal to 841 over 841, which is equal to 1. So this cos square theta plus sine square theta is 1. Okay, now let's do cos square theta minus sine square theta. So again, cos theta value is 21 over 29, so we're going to write that, and then square, minus sine square theta is 20 over 29 square, which is equal to 441 over 841, minus 20 square is 400 over 841, which leaves you with, because the denominator are same, again we can write 441 minus 400 divided by 841, which is equal to 441 minus 400, it's 41 divided by 841, and that's the answer for this equation. So that's example number 3 in your textbook. Now let's move on to example number 4. So in example number 4, they have given us a right angle triangle again. It's ABC, and angle B is the right angle, and they have given us two values. They have given us 10A is equal to 1 actually, and they are asking us to prove this equation, 2 sine A times cos A is equal to 1. So what is 10A? Again, 10A is according to that mnemonic that we are using, which was so ka cho, and in that 10 is opposite over adjacent, right? So 10A is this value, right? And what's the opposite side is BC, so this is BC is opposite, this is adjacent, and the longer side is hypo. So here we can, based on this mnemonic, we can write 10A again as, so if 10A is equal to 1, what is 10A in this? It's opposite over adjacent, so it's BC over AB is equal to 1, right? They've given us this, so basically we can rewrite this as BC is equal to AB. And just to solve this example, let's just say this is equal to K. Okay, so now we are saying that BC is equal to K, AB is equal to K, and they are asking us to prove this, 2 sine A times cos A is equal to 1. So as you see here, we need the values of sine A and cos A as well. Now we have two sides of the triangle which we have assumed as k. Side AB is k, side BC is k. But what about AC? We do not know. How can we calculate that? By using the Pythagoras theorem, right? So the Pythagoras theorem is telling you to, it's basically the longer side, AC square is equal to AB square plus BC square. So that's equal to AB is k, so k square, plus BC is also k, so k square. What is k square plus k square? It's equal to 2k square. So AC square is equal to 2k square. What is AC? We take the square root of the entire thing, and the square root of k square is k, and the square root of 2 is square root of 2. So AC is this value, right? So again, we can go in here and fill in our third side, which is k times square root of 2. Now we have all three sides of the triangle, and we can probably try to solve this equation. So what is the sine A and cos A? Let's do that first quickly. So sine A is opposite over adjacent, so the opposite is k in this, it's BC, and adjacent is AC, which is k times square root of 2. So k gets cancelled out, so we are left with 1 over square root of 2. That's sine A. What about cos A? Let's do that. Cos A is equal to, also it's adjacent over hypotenuse, so AB is the adjacent side in this triangle, right? And it's k over hypotenuse is k times square root of 2. Again, k gets cancelled out, and we are left with 1 over square root of 2. So now we have both the values, sine A and cos A. Now let's just plug it in and see if that's really true, if we can prove this. So 2 times sine A times cos A, that's equal to 2 times 1 over square root of 2, right? Sine A is 1 over square root of 2, and cos A, which is also 1 over square root of 2. And what is the square root of 2 times square root of 2? That's 2, right? Anytime you multiply two square root numbers, it becomes the whole number. For example, square root of 3 times square root of 3 is 3. Square root of 5 times square root of 5 is 5. So similarly, square root of 2 times square root of 2 is 2, and numerator and denominator gets cancelled, so we are left with 1.